Here we are on the first semester review. Let's take a look. On number 1, we're just finding the slope between 2 points. The slope formula is y2 minus y1 over x2 minus x1. Plugging the values in, I get negative 3/9, which simplifies to negative 1/3. On the second one, we're going to find the equation of the line that is parallel to this line and goes through that point. If it's parallel, my parallel slope is equal, so that's going to be 3. There's my point, there's my slope. I'm going to plug it into point slope form. So y minus y1 equals slope times the quantity x minus x1. Simplifying, I get y minus 5 equals 3x minus 3. Adding 5 to both sides gives me y equals 3x plus 2. For number 3, we're finding the perpendicular slope. So if my perpendicular slope would be the opposite reciprocal of what's given here, so I'm going to have negative 1/3 as my slope. Again, I'm going to plug that into point slope form. So y minus 2 equals negative 1/3 times the quantity x minus negative 9. 2 negatives makes a positive. Simplifying, I get y minus 2 equals negative 1/3 x minus 3, because negative 1/3 times 9 is negative 3. Adding 2 to both sides gives me y equals negative 1/3 x and minus 1. Let's take a look at number 4. If we're going to find the distance between 2 points, we're going to need the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's plug the values in and see what we come up with. x2 is negative 2 minus x1 is negative 4 squared plus 15 minus 18 squared. 2 negatives makes a positive, so I get 2 squared is 4. Negative 3 squared is 9, so I get the square root of 13. Number 5, we're looking for the midpoint of those 2 points. Midpoint formula is x1 plus x2 divided by 2. y1 plus y2 divided by 2, comma between them because it's a point that we get. Let's plug in our values and see what we get. I have negative 4 plus negative 2 over 2 and 18 plus 15 divided by 2. Negative 4 and negative 2 gives me negative 6. Negative 6 over 2 is negative 3. And 18 plus 15 gives me 33. 33 divided by 2 is 16 and a half. That's your midpoint. For number 6, find the endpoint of the segment with a midpoint there and an endpoint there. So if my midpoint is 3, 4, and one of my endpoints is negative 2, 7, how do I get from negative 2 to 3? By going up 5. So my other endpoint would be up 5 from there, which gives me 8. To get my y value, I'm going from 7 to 4, which is down 3. To get to my other endpoint, I would have to go down 3 again. So my other endpoint would have to be 8, 1. For number 7, we're looking at angles 1 and 7. They are alternate exterior angles. Number 8, what types of angles are 4 and 6? They are consecutive interior angles, or same side interior angles. Our book had 2 theorems. Number 9, if the measure of angle 2 is 98, then find the measure of angle 5. Well, 2 and 5 are same side interior or consecutive interior. We know that they have to be supplementary, so I'm going to take 180 minus the 98, and I'm going to get 82 degrees. So angle 5 has to be 82 degrees. For number 10, find the types of angles that 7 and 8 are. 7 and 8 would be supplementary or a linear pair. Let's take a look down here at some properties. For number 11, if x is equal to y and y is equal to z, then x is equal to z. That's transitive property. If x is equal to 3 and x plus w equals 14, then 3 equals w plus 14. Again, that one is substitution because you're putting in a number. And if AB is equal to AB, we know that that is reflexive. In number 14, we're looking for the pattern. The way to do that is to see how do we get from each number to the next number. You can see that we're adding 4 each time, so my next two numbers would be 14 and 18. In this one, we're going up by 3, we're going up by 4, going up by 5. So using that pattern, I would have to go up by 6 and up by 7 to get the next two numbers, 17 and 24. For number 16, you can either recognize that we're going up by 3, 5, and 7, so we would go up by 9 and 11, or you could recognize these as being the square numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared would be 25 and 36. For number 17, we're going to put true-false next to these. All quadrilaterals are rectangles. We know that is false. All rectangles are square. That's false. All squares are parallelograms is true. All rectangles are quadrilaterals. That's true. And all parallelograms are rectangles. That's false. On number 18, we're going to label these angles. This is a right angle. This is an acute angle. This is straight. And this is obtuse. On the bottom of the page, we're considering the conditional statement, if x squared equals 100, then x equals negative 10. Determine if the following are true, false. The conditional statement as it sits is, if you can find a counterexample that would make it false, and I know that x could also equal 10, so I'm going to say that's a false statement. The converse, if x equals negative 10, then x squared equals 100. That's a true statement. The contrapositive would say if x does not equal 10, then x squared does not equal 100. That would be false. And the inverse is if x squared does not equal 100, then x does not equal, and that one would be true.